And now we're going to get our OEMs to start working on how to incorporate that into new safety applications. So we'll cover that. That's the announcing. The next phase is really emergency vehicle preemption. Because we're an edge product, we have a lot of different ways to interact with the system as a whole. So if you've got a current CAD system, if you've got some pathing that comes out of your emergency vehicles for their destination, source of destination, what we're able to do then is interact with that and interact with the signal controllers. So because we have connectivity to both the back end and the local system, we can do emergency vehicle preemption in new ways. One of the things that we are working on right now with Esri is utilizing GIS data and current data coming in from the emergency vehicle in order to preempt signals proactively. So we'll walk you guys through that as well. But that's one that's coming up in the next phase. We don't have that running today. So it's just really important to see the variety of things that we're covering today, and we're doing it all with that system that Michelle showed you. Switch to connectivity at the edge compute with an application. That application can talk to all of these different devices. Sensor fusion at the edge. It's really, really important. Let me get some water, I'm sorry. When you look at IoT devices and the amount of data, there's this big problem in IoT. It's really the data sprawl. The problem is that you guys are going to have 150 different types of sensors that all put out something like temperature, right? And you're going to receive that data in 150 different ways in 150 different time slices. And I'll give you a quick example. Most of you know the company Vicella, right? They make remote weather systems. And so Vicella is a European company. They've been making weather sensors for 25, 30 years. If you get an alert Vicella, it'll be 10,000th of a degree Celsius every 5 seconds. Now, I don't even know what that means, much less need that kind of temperature, right? So if I buy a High Sierra and I buy that system I installed today, it's going to be 10th of a degree every 5 seconds in Fahrenheit. And so we get this data sprawl. The cars are going to send you in Celsius, 10th of a degree. Your roadside sensors, your Wonko signs, everything has kind of a different data format. And this is a real problem for our northbound applications. So when you look at SunGuide, when you look at the Sweries, the Panasonics, the applications that are consuming this data and giving you output, that's really tough to deal with for them. And so what we're going to show you is if you actually distribute your compute at the edge, like we're talking about, and you start retrieving that data, acquiring data at the edge, you can start to solve these big problems. You can make your systems more efficient, you can make your systems more accurate, you can make your bandwidth requirements lower, and we can make the system as a whole work much more efficiently. So acquisition. When we talk about acquisitions, this is one of the things Cisco's been doing for 30 years. We've got all kinds of interfaces on every kind of device you can imagine. I can get you an RS-485, I can get you a Wi-Fi, I can get you a DSRC. These types of interfaces are where we're able to interact with the device. The protocols that we acquire with, everything like we talked about, NTCP, SNMP, DTP, all the things you guys are familiar with and you have to deal with every single day. It's really difficult to find one system that will interact with those devices. It really is. We solve that problem. That's what we bring into our application. So acquisitions, both protocol and physical, and we apply policy to that. So if I've got that Vicella and it's spitting the temperature out every 5 seconds, I'm going to apply a policy that says, look, go get it every 30 seconds. I don't need any more than that, or every minute. And it really allows us to start fitting a data model to your data. No matter what sensor got it or how it gave it to you, we can transform it and put it in the right format. So we acquire, we can filter, we talked about deduplication of packets, dropping 80% of duplicates. That type of functionality is really important. That happens at the edge. Why would we bring that all the way back to the data center and then do some work on it just to dump it out anyways? So let's make sure we get the important stuff to us. Normalization, if I get it in Celsius and I get it in Fahrenheit, I want to make sure every single time when it comes to the applications, it's in Fahrenheit. We want to meet your data model, right? And we're not providing that data model, our customers are. So if one customer wants it 100th of a degree every 5 minutes, the other one wants it in 10th of a degree every 30 minutes, this is where we apply that data model. So it's very, very flexible and easy to use. Normalization happens for things like temperature, but it also happens for technologies. So we've been talking about DSRC, and right now what you'll see on the street is about 60%, 80% maybe of the BSMs that we saw were 2009 format of DSRC. So those are the vehicles that have been installed for at least a couple of years. 20% of those were 2016 DSRC. And of course, we didn't have C-V2X radios, so we had 0 C-V2X radios. The problem is, when those cars communicate to the infrastructure, we've got to be able to talk to all three. We can't just talk to 09 and just say the 16s aren't working. We can't talk to C-V2X and just say we're going to forget about DSRC. We've got to enable everybody at the same time. And that's where this normalization really comes in. What FDOT wants to be able to do is they want to be able to say, send all the connected vehicles a Tim's message. That's all I want to do. Your application, your SunGuide stuff should just say, hey, send this message out. Here's where I want it to go. Cisco actually handles the transformation of that, the normalization of that, so that we can send it out all three formats. It's really, really important. It's something we'll showcase for you today. Okay, so that's our normalization. Our logic and analytics is where we actually run our application. This is our sensor fusion. This is really the intelligence at the edge. This is where, when Michelle was talking about our 20 millisecond response time, that's a safety application. The US DOT says if you've got an autonomous vehicle or a safety application on the roadside, you have to be able to detect and notify or react within 20 milliseconds. That is amazingly fast. And there is no way that we can bring that data back to a data center and work on it on a data center and then react. If I'm a pedestrian and that's the only way I'm going to be saved, we're dead. We're going to have big problems. So I want it at the edge, and that's where we're putting it. So we take this industrialized hardware Cisco's been making for years, for decades. We take all that expertise at the edge, how we manage things. We push that intelligence down to the edge. And now when we run a pedestrian application, you might have a LiDAR sensor, you've got your controller, you've got your DSRC. We can make all that happen within 20 milliseconds. That's really the differentiator for us. So we're going to show all that to you today. So that's my money slide. I promise that's where I spend most of my time. Aggregation is really our ability to utilize the same application, the same amount of data, but backhaul it differently. Highly connected vehicles will be capable of actually running down our roads safely. And that's what we're driving toward. So when you see this is what we're doing now, but the amount of data that we're providing is really built for the autonomous vehicle. So that's the 5 pillars. Just to go into what you're going to see out there, we actually have these 8 intersections. So we are currently right at Alafaya right here. And so we've got from the 408 all the way down to Murdoch outfitted. We've got the basic switch. We've got our industrialized compute. And then at the 2 blue intersections, which is Lake Burge and Murdoch, we've got 4 LiDAR sensors on each corner. This is really important, and so we'll go into the LiDAR and how that's built out. But what we're going to do is we're going to take you, we're going to put you on a shuttle, we're going to drive you down the road, let you experience the applications that we interact with as we go down through Lake Burge. We have pedestrians walking over there right now. And then you'll get out at Murdoch and you'll be able to go and see the LiDAR installation, how that works, the actual cabinet, how the equipment installs, what that looks like overall. So we just want to make sure you have that info. It took a lot of work, and everybody in this room that was involved in this project, Orange County, FDOT, really took a lot. Atkins, Metric Engineering, a lot of us working together to get this done. And it was great to be able to get really detailed plans and have very competent people. So thank you guys very much for everything you did. And working this through, making sure that we understood it, doing our site surveys, very, very important. Space in the cabinet was critical. We were able to make plenty of space. They have large cabinets here, some may not. But really it was just a real lesson to be able to get through all of this and understand it, and then see kind of where the operational differences were between the as-built plans and what something like the GIS system has. And those are things that we're starting to help bridge the gap on. This is the actual intersection we've got out there. I think this is Lake Burge. And so you can kind of see the dynamic here. We've got a Walmart on one side of the road. We've got an apartment complex on the other side of the road at Lake Burge. There's a lot of pedestrians going through here. And so it's a very wide intersection, and there's a really big median in between. And so the timing of this is really important. Some of the applications that we're looking at is because now we can track the objects as they go through here. Do we ask for an extended green so that someone who can't make it across in time can make it, right? And so there are all sorts of new applications that we can come up with. And because we understand the objects, we understand exactly where they are, we can start interacting with the controllers and the vehicles out there in order to bring new applications to life. And those are the lessons that we're going through now as we go. So the LiDAR sensors are at all 4 corners. We used 4 sensors because of the size of the intersection. We wanted at least 2 beams on every object, no matter where they were. So you can kind of see the overlap in the intersection. Each sensor creates 300 megabits per second of data. So that's 1.2 gigabits per second of data that's flying. Absolutely impossible to take that back to the data center. Okay? So we've got an edge compute device that's sitting there that is crunching all these 3D point clouds together, and it kicks out an object stream. For every object, we get an object ID, we get its exact GPS location, we get its velocity vector, and we get its size and categorization. And so we take that in, and now we start creating these messages 10 times a second for every human object we see. Very interesting. And now when the vehicles receive that, it's up to the OEMs and the application providers in vehicle to start utilizing that data better. Okay? We also use this in order to send out those PSMs to vehicles, and what we'll show you is that we have an application that actually takes that, compares it to the map, and then shows the driver where those pedestrians are. So when you get on the shuttle, as you drive through Lake Burge here, if somebody is in the crosswalk here, you'll actually get a warning that they're in the crosswalk, that they're on the side of the road. That's totally configurable. It's all things that we've done with zones and everything here. So it's just part of the test that we're trying to run to figure out how this is all going to go together. Reality is that there's a lot of equipment out there. This is the existing Orange County Intellect Controller Network. So this is the network that they have, that they run and they utilize for that. We are connected to that with our edge compute device. There is a switch, and then another, this is the LiDAR compute device. So there's a separate device running all that LiDAR analytics. So it's very, very intense. We've got, because of distance, we got to install 1 PoE injector to get to the caddy corner side. And then all of this is coming back through that edge device, and all of our decisions are running on this industrial compute device. This is where we install our application. So every time you see a message come out, that was generated by this device in that cabinet. Whether it was a PSM, whether it was a TIMS, whether it was any type of message that we're sending out, that will come from that device. It gets generated at the edge in real time. Again, a real big differentiator. So a little bit of a flow, this is kind of an eye chart, but it's kind of interesting to see how much you have to do in order to really deliver a full application. And what we've got is we've got all of our different sensors here, so our traffic controller and our LiDAR sensor on the right, we're getting those inputs into that edge compute device, so this is our hardened compute. This is where we're running our software as well. This takes all of this data and creates our personal safety message for our users that are walking out there. It also creates our SPAT message. So again, utilizing NTCIP and not the connected vehicle module within the controller, we're able to create that SPAT message to save some money for our counties and cities out there. And so that's being sent immediately to the RSU and forwarded out. So those messages are being generated there. We also are bringing that then back to what we call a region broker. This region broker is where we take a long stretch of roadway and we forward data it. It's an aggregation point for us. It's out usually in cabinets, usually at an aggregation hub for your fiber. And that's typically where we'll co-locate that. The reason why we do that is because we might have all of these different RSUs going down the street. A car will be seen on maybe 4 or 8, we talked about 80% duplication of packets. It might be seen on 4 or 8 different RSUs. Each of those has a separate edge compute. So what we do is we take all that data up to our region broker, right? We want that data in the data center, but we take it here and clean it first. So that region broker might see 20 and 30 miles worth of roadway, and now we can do things like deduplication of packets. So this gives efficiencies. This structure, this tiered structure, gives us efficiencies in what we do. We can also install new applications at this layer or at the edge layer. So it's an open platform for development. We have an Esri microservice. Esri is a GIS company, and we have a microservice that allows us to correlate messages to road segments. Very, very interesting. But there's a lot of open development that we're doing. From there, we go up to the data center broker, and that's where we broker data out to applications. So this is where we would feed ATMS, the TMS system, SunGuide, any other northbound applications. We have some visualization with Esri we'll show you today, and there's a bunch of different apps, but that's really the data flow. That's how the individual messages run through our network, and that's what we're doing here in the city. And it really is that data gets isolated very, very, very quickly. And it's really hard to combine systems together. And so this is an actual customer. And they had a bunch of different clouds that they were getting outcomes from. So we had a cloud analytics provider that took some sensor data up, they did some analytics, and they gave them a dashboard. They said, here's one dashboard. So there's screen number one in the TMC, right? Okay. Then we had an ATMS provider come in and they say, hey, give us all your connected vehicle data. So here's how the flows actually went, right? So they're getting an outcome from the cloud analytics provider. Connected vehicle data goes in the ATMS system, they give them another dashboard, screen number two on TMC, right? The third one, roadway systems integrator, they're actually doing sensors in the pavement, they give them another dashboard, screen number three. And you guys know how many screens are in your TMCs. I guarantee every desk almost has 6 of them, right? And it's because of this isolation of the systems. And so the next one is, we'll use Wonka. I'll throw them under the bus a little bit, even though they're a great partner of ours. They've got a sign controller system in their DMSs, and so you've got to have another interface in order to go into that. And so there's a lot of swivel chairing happening. On top of that, though, inevitably, somebody comes to you like the National Oceanic and Atmospheric Administration, and they say, hey, I want all your weather, and we have to do this. Okay, that wasn't too bad. Now the cloud analytics provider says, hey, give us the ATMS output. Give us this other data. Okay, now we do this. All right? And then the ATMS says, hey, that is a cool output over there from that. I want that in order to help my analytics, and then we get this. We have lost our data. It's totally gone. So the DOTs, the cities, and counties, you've all put this infrastructure in. You're paying to transmit this stuff. They're giving you good outcomes and you're paying them for it. The reality is now, if you want it, how are you going to get it? If someone comes in and tells you, audits you, and says, hey, I want this to be anonymized, what are you going to do? It's a mess. It's a real big mess. And so when we come in and we actually put this broker system in, we're going to add a lot of value to data, right? We talked about the 5 pillars. I'm going to wear everybody out on it, but all the Cisco people are just, their hands in their head, head in their hands. So what we're doing though is we want to provide the exact same output for these providers, okay? We want to make sure that they don't know anything else happened. So for this cloud analytics provider, we do the acquisition of the data from the edge. The cloud analytics provider actually doesn't even have to write a driver. They don't have to go pull that sensor anymore. We're doing that for them. Okay, so we're going to feed them now. So we pull that up, we do things like normalize it. I'm going to change all the temperatures. I'm going to make it fit their data model, right? I'm going to aggregate that back. Because I don't need temperature every 5 seconds. I only want temperature every 5 minutes. Give me an average. Give me sampling of the roadway telemetry. Don't give me every packet from every call. Right? That's value. It still has a lot of value. We send that up to the data center. We persistent forward. And if you look at this now, this one sensor that used to be tied to one cloud analytics provider now has separate applications that it can feed. This is really strong. Because now if I bring up the next application and they need something, I can give it to them immediately as a live stream. That's data broker. And this is the outcome that we're after. When we look at the second provider, by the way, that cloud analytics provider does not know the difference between the first and second model. They don't have any clue. Almost 0 latency is included in that, right? Maybe a couple milliseconds total processing time. So we bring the ATMS provider in. We're doing things that are extremely, exceptionally valuable here. Deduplication of packet, dropping that 80% content, right? Context filtering. This is that Esri microservice where we can actually only give you the cars that are on the road segment you care about. That's a big deal. If I've got a business park over here and I'm responsible for this interstate, why am I listening to all the messages from those cars in the business park? Do I really care about them? No. I want to know what's on my road. And so we can actually do this as an edge microservice. It's very, very important. So now it's really clean, really accurate data. We forward it up, we persist and forward to the app. The ATMS provider doesn't know any different. Doesn't know any different at all, okay? So we keep doing this for each of these. And now what happens is now we have all the live streams sitting in the data center. We can build a single data set called temperature or weather or whatever it is, and we can publish it to the National Oceanic and Atmospheric Administration. I can say that word 3 times. And this is the power of the system when you put it all together end to end. It's the ability to now get these data sets, have control of the data, own it, If you want to use it, it's available to you. You can put it to new applications. You can give multiple destinations for your data. So now when that Google Analytics provider, I just said that name, sorry. When that Cloud Analytics provider comes back and says, hey, we want that whole data set, this is all the things that we want, we can build that as an individual data set out of the data center, and we can provide it to that Cloud Analytics application. This is really, really big. You can anonymize at this level, you can aggregate at this level, there's all kinds of policies we can apply to the data. This is the secondary outcome we have. The pri-
We're gonna invite
Okay.
the.
Yes, yeah.
All right, so,
By the way, Mark made my point for me, thankfully. So the shiny new object is actually the data and where it goes, right? And we're trying to give you those visualizations today as far as some of the demonstrations we're gonna show. So what we were gonna do is invite, when it's time, the Cisco people and our partners that are here, we're gonna have you go out and get on the shuttle when it's time. And we're gonna invite our FDOT customers and our cities and counties to come forward, and we're gonna kind of show you on the screen the connected vehicle data that when the shuttle drives around. And then we're gonna divide y'all up, those folks, the FDOT and our cities and counties, and we're gonna have you see some additional demonstrations. Yep, I'll have Mark go through them.